Good morning. Today we're doing lesson 10.2, which is continuing to graph parabolas. Here's that word again, which has to do with this curve. The other day we looked at graphing y equals x squared, which looks something like this. It goes through the origin, and we had the points 0, 0, 1, 1, and 2, 4. We plug those into our equation, y equals ax squared, or just x squared. And then we also added c, which moved our graph up and down. Now, today we're adding in the middle piece, b, which is going to help move our graph left to right. So c was moving our graph up and down, and b moves it left to right. But it's not just straight up and down and straight left to right. There are some formulas that we have to use. So, quick review of what we learned last time. First, the graph of ax squared plus bx plus c is a parabola that opens up if a is greater than 0. So if here we have the number 4x squared, that's going to be a graph that's opening up. Any positive number opens up, and opens down if a is less than 0, so any negative number. So if a is positive, up. If it's negative, down. We said it's a narrower graph. We call that a stretch. It's sticking our arms taller up into the air. Our graph is narrow if a is greater than 1. So if we have a here that's a positive 2 or positive 5 or negative 5. It doesn't matter if it's negative or positive. If that number is greater than 1, it's a stretch. It's wider, or we call it a shrink, if a is, like an L, less than 1. So like 1/2 or 2/3 or some number that is absolute value is less than 1. So here are the new pieces we have in the box. It has an axis of symmetry, we abbreviated that AOS, and then here's our little equation or formula that we need to use. In the past, our axis of symmetry was always when x is 0, because our graph didn't move left to right, it only moved up and down. Now, our axis of symmetry, the x part of the point, x first, can be found by using this equation, negative b over 2a. So a, b, and c again come from our equation a, b, and c right here. So we take the opposite of b and then divide it by 2 of a. That will give us x. Then you need to plug whatever you get in for x into your equation. So I'm going to say to find y, we plug x into equation. So if we find out that x is, let's say it's 1, 2 on this graph, we found on our x-axis we're going to go 2 to the right. Then we're going to plug that in here and solve this equation to figure out what is y going to be. And that'll tell us our vertex, that point there, right there, x, comma, y. So it says it has a vertex with an x coordinate of, okay, they told us right there, that's x. You plug it in to find y. The point right here that we used c before told us our y-intercept in the before. But that was before when our axis of symmetry was also 0. So our axis of symmetry was this point where it goes through the vertex, our x number, but our y-intercept is simply what c is. So before that was our vertex, now that's just a point that we are going to reflect across the axis of symmetry, because symmetry means it's symmetrical, it's the same on both sides. So if we're 1, 2 squares away from the axis of symmetry here, we'd be 1, 2 on this side as well. So notice 1, 2, 1, 2, we reflected that across. This was point C, like 0, c, that came from this number here. This is what we call C prime. It's reflected across the line of symmetry. So we'll get to graphing that here in a minute. So first, find the axis of symmetry of the graph of the function. So our axis of symmetry was where we're crossing our x-axis at negative b over 2a. Just like we learned right back here, axis of symmetry, negative b over 2a. So if you want to write out what a, b, and c are, you can. A in this equation is a negative 2. b is 12, and c is negative 7, because this is ax squared plus bx plus c. So I just wrote those out. So we have negative b, and b is 12, over 2 times a, and a is negative 2. So we have negative 12 over negative 4, which makes a positive 3. So our axis of symmetry is 3. If you want to put that on here, you can. 1, 2, 3. And I always use a dashed line to show our axis of symmetry. So here's that. And then find the vertex of the graph. So our vertex, we know x is 3, so we're going to plug this into our equation to find y. We need to find that point, x comma y. So our equation, we have y equals negative 2, x is a 3, so we have 3 squared, plus 12 times x again, and x is still 3, and then minus 7. So order of operations tells me to do my exponent first. 3 squared is 9. So 9 times negative 2 is negative 18. 12 times 3 gives me 36. And then minus 7. Going straight across from left to right, negative 18 plus 36 should give us a positive 18. And then minus 7 gives us a y of 11. So this is our y to our point. X is 3, y is 11. That's our vertex. So 3 and up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right near the top. If you want to plot that on there, like 3, 11, you can. And then our last step that they didn't really say to do on here, but it did say find the axis of symmetry in the vertex. C is where our graph crosses the y-axis. So we're crossing at a negative 7. Negative 1, 2, 3, 4, 5, 6, 7. That's C where we cross. And notice C is 1, 2, 3 squares away from my axis of symmetry. So 1, 2, 3 on this side is where our C prime would be, where our graph is going to create our parabola. I know this is really hard to do on here. Oops. Do your best to create a nice parabola. This is a little wobbly. Create a better line there. And there's our parabola. Let's try another one. Here we have all the steps this time. Find the axis of symmetry in the vertex. If you want to identify these before, you can. So for example, A is just a 1 here. I'm going to label A, B, and C. B is a negative 2, and C is a negative 3. So this graph, we know from A in front opens up. So that's what your graph should look like. It should be opening up eventually. Find the axis of symmetry, okay? X is negative B over 2A. So we have negative B, and B is also negative. So we have the opposite of a negative 2, that's going to become a positive. And then 2a and a is 1. So we have 2 over 2, which is really just 1. So our axis of symmetry is when x is at 1. This is where our graph's going to fold in half, be symmetrical. So to our point, we know x is 1. That our vertex has to be on that line in order for it to fold in half. We need to find y. So let's plug in x right there. We know it's a 1. So we have 1 squared minus 2 times 1 minus 3. Well, 1 squared is 1. 2 times 1 is 2. So we have 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So down 1, 2, 3, 4. There is our vertex. So we found our axis of symmetry. When x is 1, we found the vertex, which was 1, negative 4. And then plot the 2 points. One should be C. 0, comma c is our point. Negative 3. 1, 2, 3. There's c. And we reflect it across our axis of symmetry, which was that line. So it's 1 away on this side, so 1 on the other side. Here's c prime. And here is our graph. It's going to look something like this. We don't know where this graph is going to end up, but we reflected the points and we drew our parabola. If you wanted to make an XY table to know exactly where the other points might be out here, you can, but you don't need to. For example, I don't know where this is going to end up necessarily. If you just want to make it small like this for now, that's fine. Alright, here's another one. Label the vertex and axis of symmetry. First of all, this one, A is negative, so I know this is going to open down, so it's going to be a graph like this. Find the axis of symmetry. So our axis of symmetry is negative B. So I'm just going to label this A, B, and C. Negative B and B is 6 over 2 times A, and A is a negative 1/2. So I have negative 6. 2 times negative 1/2 is going to be a negative. Half of 2 is 1. So this is really just 6. X and Y. So our axis of symmetry is at 6. I'm going to go, you know what, I've graphed this one before, which I probably shouldn't tell you because I'm biased now, but I'm going to find my point first before I actually plot anything. So I found my axis of symmetry, I'm going to find my vertex. Because I know X is 6, let's find Y. So we have negative 1/2, and then we have 6 squared. Plus 6 times X, and X is 6, plus 3. Well, 6 squared is 36. Half of 36 would be 18, and it's negative. 6 times 6 is 36, and then plus 3. If we have a negative 18 and a positive 36, well, 18 2 times is 36, so we have a positive 18 plus 3 will give us 21. So this point, 621, isn't going to fit on here, so I need to go by a different number than maybe 1s. If I go by 3s, I can go by the same scale on both axes. 3, 6, 9, 12, 15, 18, 21, 24, and that should do it for us because my axis of symmetry is 6. So we can make a dashed line at 6. There's our axis of symmetry where my graph will fold in half. And our vertex is at the point 21. And we said earlier this graph is going to open down, so it better open down when we plot C. 0, comma C is at 3 right there. So we're 3, 6 on this side, 3, 6 on this side. There's C prime. And then graph your parabola. There we go. We reflected our points and drew our parabola. Alright, a couple things here. It says minimum and maximum values. For our equation, our parabola, or our quadratic function is what these are called, the y-coordinate of the vertex, so we know x tells us where it is left and right, that's our axis of symmetry. The y tells you where it is on that line, right, up or down. It's either a minimum if it's a is greater than 0, so if this is a positive number like 2x squared, we know it's going to open up. And it's a maximum if a is less than 0, like the whole graph is below it, right? It's a negative. That's something we learned the very first day last time. If a is positive, it opens up, which means this point down here is the minimum of our graph. If it's negative, it opens down, which would make it the maximum of our graph. So without actually graphing it, we need to tell whether this has a minimum or a maximum value. Then find the minimum or maximum value. So because a right here is positive, I know it's going to open up. So if this graph is opening up, the vertex is going to be a minimum because it's at the bottom of the graph. So we need to find that point. What is that minimum point, the vertex? So first I'm going to find x, which is negative b over 2a, so negative b, which is 18, over 2 times a, which is 6. Reminder, these are just a, b, and c. So we have negative 18, 6 times 2 is 12. So if I simplify this, I'm going to divide by 6. 6 times 3 is 18, 6 times 2 is 12. So negative 3 over 2 is really negative 1.5. So that's x. We need to plug that back in and find y. So if this is x, y, we have, remember f of x is a fancy way of saying y, it's just in function form. We have y equals 6 times x squared, so negative 1.5 squared, plus 18 times negative 1.5, and then plus 13. So I'm going to plug this part into my calculator. If you want to plug in the whole thing, you can. 6 parentheses negative 1.5 squared plus 18 times negative 1.5 plus 13. And we got, what was that, a negative 0.5 for y. If you wanted to do it separate, that's fine too. But we found our vertex, and it says find the minimum or maximum. Well, we did. That minimum right here on our graph would be at the point negative 1.5, negative 0.5. Same thing with the next one. Tell whether it has a minimum or a maximum, and then find it. Find the vertex, because they're asking what is the minimum. That's the vertex. This one, because it's negative, was going to open down. And if this opens down, that point is the highest point, which would be our maximum. So first let's find x, negative b over 2a. And b is already negative, so those two negatives are going to make a positive. Over 2 times a, and a is negative 3. So we have 12 over negative 6. 12 divided by 6 is just 2, so we have negative 2 for x. Then we need to plug that back in and find y. This one's a nicer number to plug in. We have negative 3 and then x squared, so negative 2 squared, minus 12 times negative 2 plus 10. This one I'm just going to do by hand. Negative 2 squared is really a positive 4 times negative 3 is negative 12. A negative times a negative here is going to make a positive 24. And then negative 24 and a positive 12, that makes 12. 12 plus 10 is going to give me 22. So that vertex, if you were to graph it, the axis of symmetry would be at negative 2, and then our vertex would be way up here at 22 somewhere. And this was a graph that's going to open down because we know a is negative. You didn't have to graph it. I'm just showing you what that would look like. Alright, these last two, find the zeros of the polynomial function. That's what we're going to be working on, a little introduction to 10.3. We actually learned how to do this already, but not in the form of a graph. If you're in 6th hour, you did not learn this, so you can skip this question. However, if you were in hours 1 or 5, we did learn this already. We learned to find the zeros of the function. That's where our graph crosses the x-axis. What are the 2 points that our parabola is going to cross the x-axis, where it's going to hit when x is 0? So we learned this by multiplying our first and our last term and putting on the top of our diamond 2x squared. Our middle term went on the bottom, 1x. Then we need to figure out what multiplies to get 2 but adds to get 1. well, the only thing that multiplies to get 2 is 2 times 1. Oh, you guys, I was supposed to make a mistake. I was supposed to change this. Add a 3 here. This is supposed to be a 3x. I made a mistake when I created this problem. So the only things that multiply to get 2 are 2 times 1, which we'll add now to get 3. From here, we used a box to help us factor this polynomial or quadratic function here. So we have 2x and 1x, those go on the diagonal here. Our first term from the equation goes in the first box. Our last term from the equation goes in the last box. And we thought, what multiplies to get 2x squared? Well, x times x. And this row both has a 2, so we need the 2 up here. 2 times 1 is 2. 1x times 1 would still give you 1x. 2x times 1 would still give you 2x. And 1 times 1 is 1. Oops, I didn't need the x in this last one. Our last term was just 1, not 1x. So our two sets of answers, we had 2x plus 1, and we had 1x plus 1. Finding the zeros or finding when y is really equal to 0. It's when it's crossing the x-axis, or when y has reached to 0, right? So this is really y, so that's really a 0 when y is at 0. I think I said x earlier, I meant when it's crossing the x-axis. So we simply just have to solve both. 2x plus 1 equal to 0, and 1x plus 1 equal to 0. Because if it's equal to 0, either this has to be equal to 0, because it's multiplied, or this has to be equal to 0. So we're going to solve both. So get rid of addition and subtraction. We're going to subtract 1. We have 2x equal to a negative 1, and then divide by 2. So we have x equals a negative 1/2 or negative 0.5. On this side, same thing. 1x is really just 1, so if you divide by 1, nothing's going to change. X is going to be a negative 1. So what that means is this graph is going to cross at negative 1 and at negative 1/2. We knew this one opens up because it's a positive a, so our graph might look something like that. That's where it's crossing. Oops, I didn't do a very good job there. So we actually learned how to find these two numbers previous. We're going to use these two numbers later on lesson 10.3. Let's try one more using our diamond and our box to find our factors, or the zeros of the function. So remember, multiply a and c to get the top number. That's a negative 15x squared. And b on the bottom is 2x. So what multiplies to get 15 but adds to get 2? Well, 1 and 15 won't work. The only other numbers are 3 and 5. 3x and 5x. Well, we need more positives, so the 3 better be negative. 5 minus 3 is 2. To add to get 2 and multiply to get 15. So we have a negative 3x and a positive 5x. Our first term was negative 3x squared. Our last term was 5. So we have x times x gives us x squared. The negative 3 looks like it needs to go on the top because both of these have a negative 3 in it. And then x times 5 is 5x. 3x times 1 would still give you negative 3x. And 5 times 1 is 5. So our two sets of parentheses, or our factors, are negative 3x plus 5 and x plus 1. So if we're finding the zeros, it's when y is 0 here. So we have 0 equals negative 3x plus 5, and 0 equals x plus 1. And just solve both. So subtract 5. We have negative 5 equal to negative 3x. and then divide by -3. We know two negatives make a positive. Oops. So x is going to equal 5/3, or 3 goes into 5 one time, and you have 2 pieces left over. If you want to write it as a decimal, 1.6 repeating, that's fine too. Either one will work. The other side's a little bit easier, just subtract 1, and x is -1. So this one, our graph would cross at -1 and at 1.6. This graph was negative, so it might look something like this. Oops, missed the point, but you get the idea. Alright, your homework is out of the book. You have to do question number 1, and then 5 through 11 odds, 15 through 21 odds, just number 28, just 33, and just 41.